You're welcome to Exam Scholar channel. If this is your first time of coming across this channel, kindly subscribe to this channel and click on the notification icon to get notified when we release videos. So what are we learning in this video? This video is a continuation of what we have been learning so far, which is wave. We are learning sound wave. Make sure you watch the previous video. If you are just watching this video, watch the previous video. Now, what are we going to learn in this video? We are learning stationary or standing wave. We want to look at vibration of string and vibration of air in column. You recall that I've explained the meaning of standing or stationary wave. I explained that these are type of wave in which the energy is in between the vibration that is taking place. So there will not be energy transfer from that place to another place. So the energy will be in the system of the vibration. That is stationary wave. Now, stationary wave happens when another wave is being generated, when a wave is produced and there is another wave that is generated, which is known as interference. To start with, let's quickly look at vibration of string. How can we make string to vibrate? It's very simple. If you have a string can be a melter, a very tiny melter that is having a particular length, or a rope, a small rope that is made from polymer, either it is made from nylon or polymer. Now, you fix it at both ends. The both ends are fixed. Then you can strike the string. Once you strike it, it will start vibrating as shown. Let's look at the mode of vibration. You see that this string is having a particular length from here to here. Now, when it is vibrating, it's forming this pattern. Now, let's calculate the number of wavelengths that is being formed. Now, in my previous video, I've explained how you can easily fix this. I said for one wavelength of vibration, we are going to have 4 parts. Remember? So if you look at this very well, from here to here, we have 1, 2. You just need to pick one out of it. So you have from here to here 1, then you have 2 out of 4. So which means that this one is half wavelength. 2 wavelengths over 4. That will give you what? Wavelength over 2. So this one is wavelength over 2. The length corresponds to what? Wavelength over 2, lambda over 2. Now, which means L is equals to lambda over 2. Make lambda solve the formula by cross multiplying. You have lambda is equals to 2L. Then you remember that V is equals to F lambda. Do you remember? Yeah. Now, this is the first pattern that is formed. Now, let's call the first pattern that is formed, let's call it fundamental tone. The sound that you are going to hear when you pluck this string, let's call it fundamental tone. Okay? Now, that sound is going to have a frequency. Now, the frequency, we call it fundamental frequency. Now, so which means that V, the speed of the sound that you hear or that you are going to hear, will be equals to what? The frequency of the sound multiplied by the wavelength. So that is what we have here. So we have fundamental frequency multiplied by the wavelength. Now, make your fundamental frequency solve the formula. So you have F1 is equals to V over lambda. Now, when you see lambda, what can you put there? You can put 2L. So you have V over 2L. So which means that the fundamental frequency here, coming from fundamental tone, we call it F1. The first sound that you are going to hear when you pluck it here. So you call it fundamental frequency. So, and it is also called first harmonic. First harmonic. Now, what is the value? First harmonic is equals to velocity divided by 2L. That is for fundamental frequency, also known as first harmonic. Now, what if you are still using the same length and you have something in between the length? You hold it or you fixed the middle and you pluck it. You are going to have this pattern as shown. Now, this is called second harmonic or first overtone. The sound that you are going to hear from this is called second harmonic sound or first overtone sound. Recall that the length is constant. Okay, now if you look at the wavelength that is formed here, how many wavelengths is formed here? From here to here, we have 1, 2, 3, 4. 4 out of 4. So making one wavelength. So this thing corresponds to what? A single wavelength. So this length will be what? Lambda will be equals to the wavelength. Okay, wavelength simply means distance between a complete oscillation. From here, it completes an oscillation, and if you measure it, it is L. Okay, now let's go. So L is equals to lambda. Lambda is equals to L. Now you recall that V is equals to what? F lambda. Now the sound that you are hearing here is second harmonic. The frequency will be what? Second harmonic frequency. So let's call it F2. That is why V will now be equals to what? F2 lambda. Okay, now make F2 solve the formula. F2 will be what? V over lambda. Substitute the value of lambda here, so you have V over L. So this is known as overtone. Now be careful. This stand is now called overtone stand. Overtone are the multiples integers of the first resonance frequency, which means first harmonic. The frequency, the multiples are called overtone. Now you have a sound that will be what? That the frequency will increase. The frequency will be high, the pitch will increase. Okay, now we call it overtone or second harmonic. F2, second harmonic, is also known as what? First overtone. Second harmonic is what? First overtone. Second harmonic is also known as what? First overtone. F2. Now, F2, which is the first overtone or second harmonic, will now be equals to what? V over L, vibration of string. Now let's move to the third one. Let's say you now have this pattern. You fixed 2 points and you try to strike this string. You are going to hear some sound. The sound that you are going to hear is going to be what? Third harmonic sound or second overtone sound. Okay, now look at this very well. Let's try to count the number of oscillation here. You can do it this way. This is a complete from here to here, 1, and this is half, 1 and a half, which is 3 over 2 lambda. You don't want to do it that way. Count it. 1 from here to here, 1, 2, 3, 4, 5, 6. You have 6 lambda over 4. Complete is 4, so you now have 6. 6 lambda over 4. When you do it, you get what? 3 lambda over 2, which is also what? 1.5 lambda. Okay, now L corresponds to what? 3 lambda over 2. So let's quickly do that. L is equals to 3 lambda over 2. Make lambda solve the formula. You have 2L over 3. When you try to make lambda solve the formula here, you have 2L over 3. Now V is equals to what? F3 lambda. Because the sound that you're going to hear here will be of higher pitch. So it's going to have its own frequency. Make F3 the solve the formula. F3 will what? V over lambda. Substitute for the value of lambda here. So you're coming from mathematics, you don't need to stress yourself, you just need to carry this 3 and bring it up. So you have 3V over 2. That is what? F3. F3 is known as what? Third harmonic or second overtone. So we call it third harmonic or second overtone. Third harmonic is still the same thing as second overtone. Okay, so let's put the value here. Let's look at the fourth one. For the fourth one, we call it fourth harmonic sound or third overtone sound. Now, so which means that we are going to fix 3 points in the middle here. 1, 2, 3. So 3 is fixed here in the middle. When you try to pluck or strike this string, you are going to hear a sound. The pitch of the sound will have increased, so it's going to have its own frequency. Okay, don't forget that the length is constant. The length is still the same here. Now let's look at the number of oscillation made here. From here to here, that's 1, that's 2 oscillation, 2 lambda, 2 complete oscillation or 2 lambda. Now if you don't want to do it that way, just count it from here to here. 1, 2, 3, 4, 5, 6, 7, 8. 8 lambda over 4, and that is 2 lambda. So now I have 2 lambda. Quickly, we have L is equals to 2 lambda So lambda will be what? L over 2. Okay? Record that V is equals to F lambda. So we have V is equals to F4 lambda because this sound we have its own frequency. Okay? As it is vibrating. Now F4 will be what? V over lambda. Isn't it? Substitute for the value of lambda here. So you have V. Quickly solve this using maths. You have 2V over L. So F4, which is known as what? The fourth harmonic. You see, I've changed it to harmonic. You can call it harmonic overtone. Fourth harmonic, but it's going to be fourth harmonic, not fourth overtone. Fourth harmonic, which is also known as what? Third overtone. Get this. The first frequency here is known as fundamental frequency, which is called first harmonic. Every other one will now be overtone. The next one will be what? Second harmonic, which is known as first overtone. The next one will be what? Third harmonic, which is known as what? Second overtone. The next one will be what? Fourth harmonic, which is known as what? Third overtone. Okay? So you write it here. F4 is equals to 2V over L. What do we want to do here? Let me show you what we want to do here. Now let's write it like this. Let's find the ratio of the frequency that we have gotten so far. So F1 ratio F2 ratio F3 ratio F4 will be what? We find the ratio like this. Now, if you find the ratio F1 ratio F2 ratio F3 ratio F4 will be V over 2L ratio V over L ratio 3V over 2L ratio 2V over L. Now, if you look at this very well, let me quickly solve this for you. I don't want to bore you. Now, you see, this V over 2L, if you divide all this ratio by V over 2L, let's see what we are going to get. So dividing it, it means that you multiply it by what? 2L over V. So F1 ratio F2 ratio F3 ratio F4 will now be what? V over 2L times 2L over V ratio V over L times 2L over V ratio 3V over 2L times 2L over V ratio 2V over L times 2L over V. This is what we are doing. All these things that are gotten from when we are doing the analysis here, you just multiply 2L over V by them. So you get this. Yeah, let's simplify our expression. 2L here can cancel 2L here. V can cancel V here. So we have all these things will be what? 1. This one will turn to 1. Let's look at this one. L will cancel L here. V will cancel V here. All this one will turn to what? 2. 2L will cancel 2L here. V will cancel V here. All this one will become 3. L will cancel L here. V will cancel V here. You will have 2 times 2 here, which is 4. So which means that we are going to have what? F1 ratio F2 ratio F3 ratio F4 will be what? 1 ratio 2 ratio 3 ratio 4. Now you can extend this formula. Oh yeah, what would that be the value of if you add another things to it? Let's say you find F5 ratio F5. So the next one will be what? Ratio 5 ratio 6 ratio 7 ratio 8 ratio 9. So if you continue to find the higher overtone and harmonics like that, so you get 1 ratio 2 ratio 3 ratio 4 ratio 5 ratio 6 ratio 7 ratio 8 and the like. So this is the ratio of the frequency. So once you know the frequency of the fundamental tone, you can know the frequency of any other harmonics or overtone for vibration of string. Now for vibration of string, we have even and odd harmonics. So this one is odd, even, odd, even, odd, even, odd, even, something like that. So they have even and odd harmonics. Write this thing down. This is part of the question that used to come out in your exam. Vibration of strings has even and odd harmonics. Even and odd overtone, even and odd harmonics. So we have considered vibration of string. Let's consider vibration of air in colon or in pipe. For instance, the instrument, wind instrument. This is the working principle of wind instrument. The other one that I explained, that is the working principle of string instrument. Now, let's look at this one very well. Pipe can either be open or closed. Let me give you a practical example. A recorder is an open pipe.
an open colon. Now, when you use something to block the end, you now form a closed pipe. Recorder is an open colon or open pipe. So blocking the end will now make it to form a closed pipe or closed colon.
Now, the first pattern that you have, as we all know, is called what? First harmonic. So you are going to have something like this. You are going to have this pattern. Okay? Now, your colon is going to have length. So let's call it L as shown. Now let's count the number of oscillation or the wavelength. Don't forget the idea. A complete wavelength is 4. Now let's look at this one. From here to here is 1, 2. So this one is 2 out of 4. So which means this length corresponds to what? Lambda over 2. Half. 2 out of 4 is half. So this one is what? L is equal to what? Lambda over 2. Now make lambda sort of formula. Lambda will be 2L. V will be equals to what? F1 lambda, as I've explained in vibration of string, is similar. So you have what? F1 is equals to V over lambda and is equals to V over 2L. So let me be fast because it's almost the same thing as vibration of string. Now, fundamental tone. So you have F1, you have this. F1 will be what? First harmonic, and you have this. Now, the second pattern, which is known as what? Second harmonic or first overtone. This is the pattern that you're going to get. Let me quickly explain. Let's count the number of oscillation here. You see, starting from here, ending, that is a complete oscillation. You don't want to use that method, you just count it this way. 1, 2, 3, 4. 4 out of 4, that's 1. So we have L is equals to lambda, lambda is equals to L, V is equals to F2 lambda, and then F2 will be what? V over lambda, which is equals to V over L. So overtone or second harmonic. So you have F2, which is known as what? Second harmonic or what? First overtone. So you write it here. Okay, F2. Now, the third pattern, which is called third harmonic or second overtone. Let's count the number of oscillation. You can see that it's 1.5. From here to here is 1. Here, half, 1.5. Or 3 lambda over 2. Or let's count it. 1, 2, 3, 4, 5, 6. 6 out of 4. That's 3 lambda over 2. So we have L is equals to 3 lambda over 2. You have lambda is equals to 2L over 3. Then you have V is equals to what? F3 lambda. Then you have F3 is equals to what? V over lambda, right? When you make your F3 sort of formula, so when you put the value of lambda, you have V over 2L over 3, then you have 3V over 2L. So it is also known as what? The overtone is called what? Second overtone or third harmonic. Third harmonic or second overtone. So you go ahead and put the value here. Now to the next one, which is what? Fourth harmonic or third overtone. Don't forget the length is constant. Now if you look at it, how many complete oscillation? 1, 2. This is complete oscillation 2. But you count it here 1, 2, 3, 4, 5, 6, 7, 8. 8 lambda over 4. That's 2 lambda. So L is equals to 2 lambda. Lambda is equals to L over 2 when you make your lambda set of formula. When you try to make your lambda set of formula, so when you try to make your lambda set of formula, now V is equals to F4 lambda. And you have F4 is equals to V over lambda. So you have V divided by what? L over 2. And you have 2V over L. So we call it what? Fourth harmonic or third overtone. So which is this value? Don't forget that the sound that you'll be hearing from all this stuff, and when you have something like this, the sound that you'll be hearing will increase in frequency. Will be increasing in frequency. This is how we used to do this thing. Now your flute, your recorder, as you are placing your hand like that in that hole, this is what you are forming. As you are placing your hand in that hole, you are forming this. Okay? Now if you continue solving it, you have this F1, F2, F3 is equals to this, F4 is this. Now If you find the ratio as usual, you do something like this that I've done in the vibration of string. Now you multiply all through by these things. This thing is still the same thing as what we have gotten in vibration of string. So just apply the same method. When you do it, you have F1 ratio F2 ratio F3 ratio F4 will be what? 1 ratio 2 ratio 3 ratio 4. So which also means that open pipe has what? 1 ratio F2 ratio F3 ratio F4 will give us what? 1 ratio 2 ratio 3 ratio 4. So if you continue like that, you get ratio 5, ratio 6, ratio 7, ratio 8, and the like. So open pipe has even and odd harmonics. Open pipe or open colon has even and odd harmonics, just like vibration of string. Okay, we want to look at closed pipe this time around. Now let's look at closed pipe. For closed pipe, you have something like this, and you have this shape being formed. Okay, now let's look at the number of complete oscillation here. You can see that this one is what? 1 out of 4. This one, you can see it clearly. This is 1 out of 4. So this one is what? Lambda over 4. L is equal to what? Lambda over 4. Make lambda solve the formula. Lambda is equal to 4L. So you have V is equal to F1 lambda. The sound that will be produced here as the air vibrates is known as fundamental tone. Fundamental frequency. It's going to have fundamental frequency. Now, fundamental frequency F1 will be V over lambda. Just so to the value of lambda, you have V over 4L. V over 4L. Which is called fundamental tone and first harmonic frequency. First harmonic frequency. So which is F1 is equal to V over 4L. Now, this one is called second harmonic or first overtone. You have this pattern. For second harmonic, which is known as first overtone, you have this pattern. Yeah, let's observe it. From ear to ear is 1, 2, 3. 3 out of 4 complete oscillation. So we now have what? Is equals to 3 lambda over 4. Make your lambda set the formula. Lambda is equals to 4L over 3. Please, as you are watching this video, take note of each diagram. For first harmonic, second harmonic, third harmonic, and you just need to know the harmonic. For the overtone, you know that the second harmonic, that is where overtone is starting from. Second harmonic will be first overtone. Just master the diagram. Please master the diagram. Master the diagram. And once you master the diagram, you don't need to cram anything here. Now, lambda is equals to 4L over 3 here. So you have V is equals to F2 lambda. Then you can make F2 solve the formula. F2 is equals to V over lambda. Now V over 4L divided by 3. Once you solve this, just substitute for the value of lambda inside this formula. You get this 3V over 4L. So what are we talking about here? Second harmonic, which is also what? First overtone. Put the value here. F2 is equals to 3V over 4L. Okay. Let's look at the third one, which is third harmonic or second overtone. Look at the diagram. Okay. Now let's count the number of oscillation from here to here. 1, 2, 3, 4, 5. This is 5 out of 4. You see that the techniques I'm using actually works very well. From here to here is 1, 2, 3, 4, 5. 4 is the complete oscillation. This one is now 5. 5 lambda over 4. So we have L is equals to 5 lambda over 4. So when you make lambda solve the formula here, lambda will be what? 4L over 5. Don't forget V is equals to what? F3 lambda. And then F3 will now be what? V over lambda. Substitute the value of lambda inside this. Lambda is 4L over 5. You have V over 4L over 5. So when you solve this, 5 will come up. 4L will be here. 5V over 4L. That is F3. Now, F3 is overtone, right? Which is known as third harmonic or second overtone. Put the value here. We have the value being written here. We use it later on. Finally, let's add the fourth harmonic, which is known as third overtone. Fourth harmonic, third overtone. Something here. You have 1, 2, 3, 4, 5, 6, 7. 7 out of 4. So you have L is equals to 7 lambda over 4. Try to make your lambda solve the formula. So you have lambda is equals to 4L over 7. V is equals to F4 lambda. So you have F4 will now be what? V over lambda. Substitute the value of lambda inside this. So you have V over 4L over 7. So your F4 will be what? 7V over 4L. So let's just put it down here. Before putting it down, we know that this is harmonic. You can call it harmonic. F4, which is the fourth harmonic, also known as what? Third overtone. Okay? Now let's put it here. Let's see what will happen next. Now we have written them here, what we have calculated. To find the ratio, let's do what we used to do before. I want to break this down very fast. Now this is what we are going to do. Just go ahead and pick the F1, the value, divide it by every other thing. Okay, that is what we have here. So we are going to have F1, which is what? V over 4L times 4L over V. Ratio, what is F2? What we have here? 3V over 4L times 4L over V. What is F3? 5V over 4L. Then you multiply 4L over V with it. Then you have F4. You have 7V over 4L times 4L over V. So that is the ratio. So when you do that, let's quickly solve it. 4L can cancel 4L here. V can cancel V here. Everything here turns to 1. 4L will cancel 4L here. V will cancel V here. Everything here turns to 3. 4L will cancel 4L here. V will cancel V here. Everything here turns to 5. 4L will cancel 4L here. V will cancel V here. Everything here turns to 7. 7. What will not be the ratio of F1, ratio F2, ratio F3, ratio F4? So we are going to have 1 ratio 3 ratio 5 ratio 7. F1 ratio F2 ratio F3 ratio F4 the 1 ratio 3 ratio 5 ratio 7. What do you observe for closed pipe? Closed pipe has odd harmonics. Closed pipe has odd harmonics. So if you want to increase this, the next one will be what? 1 ratio 3 ratio 5 ratio 7 ratio 9 ratio 11 ratio 13 ratio 15, continue like that, because this is closed pipe and is having odd harmonics. Odd harmonics. Odd harmonics. Now let me ask you a question here. What will be the ratio of the sixth harmonic? The ratio of the sixth harmonic will be what? We have 9 and 11. 11. Okay. What is the ratio of the seventh overtone? Seventh overtone will be 8th harmonic. That is how to answer the question. You just need to find the 8th harmonic. Just count this number up to 8. The value will correspond to 7th overtone. So what have we learned so far? So we're able to learn vibration of string, and we see that it has even and odd harmonics. This is the ratio of the harmonic frequency. The first frequency, first harmonic ratio, second harmonic ratio, third harmonic ratio, fourth harmonic. Okay? The fundamental frequency ratio, first overtone ratio, second overtone ratio, third overtone is 1 ratio 2 ratio 3 ratio 4, and it continues like that, even and odd harmonics. Don't forget vibration of string. Don't forget the diagram for each harmonic. We talked about pipe. We talked about open pipe that is having similar pattern with string. For open pipe, it also has even and odd harmonics. The ratio F1 ratio F2 ratio F3 ratio F4 is 1 ratio 2 ratio 3 ratio 4. Now for closed pipe is having odd harmonics, so which means F1 ratio F2 ratio F3 ratio F4 will be 1 ratio 3 ratio 5 ratio 7. So we have seen vibration of string, vibration of air in column or pipe. For string, what we just learned is the brain behind the designing of guitar. Here for pipe, it is the brain behind wind instruments. This is the brain behind string instruments. Subsequently, we are going to learn how to use this thing to solve some question. So make sure you watch the next video. This video is just for explanation. The next video will be basically for calculation. So make sure you like this channel, subscribe to this channel, love this video, comment in the comment section. Are you able to learn one or two things? All right, till then, bye for now.